Hi, everyone. Thank you for attending today's webinar, Achieve Statewide HD Maps and Models at Scale. My name is Emily Reitz, and I'm the Senior Manager of Applications and Technology at the National States Geographic Information Council, or NSGIC. If you are unfamiliar with our organization, NSGIC exists to advance effective national coordination of geospatial information by supporting state-level cooperation. We serve as a national forum for the development of capable and future-oriented geospatial leadership. If you'd like more information on how to get involved with us, please visit our website, nsgic.org, and I'll put that in the chat shortly. Just a couple of reminders for our call today. All attendees have been muted on entrance, and there will be time at the end of the presentation for Q&A. So please place your questions in the chat box, and they potentially will be answered during the presentation, or they will be read aloud at the end of the presentation. Additionally, a recorded version of this webinar will be made available afterwards, so be on the lookout for an email with that information. And with that, I will turn it over to Travis. Thank you so much for joining us.
All right, thanks, Emily. Well, hello, everyone. Again, my name is Travis Gelati. I'm the Director of Technical Content Solutions and the Product Manager for the HxGN Content Program. I'm here today to provide a brief update on who we are for those of you that don't know and where we're headed with the HxGN Content Program in the next couple of months. So with that, we can get started.
Looks good.
All right, great. All right, so I'd like to begin today's discussion by reviewing the HxGN Content Program in general, in case we have some newcomers in the audience, or some of you may have not been playing along at home very well during the other webinars that we've delivered over the past couple of months and at the in-person conferences. So what is the HxGN Content Program? The Content Program offers an off-the-shelf licensed orthoimagery data product that is one leaf-on, 4-band data and is refreshed on a 3-year cycle. Our current data library covers the entirety of the United States and Western Europe. In the US, we have a blend currently of 6-inch and 1-foot data. However, as most of you are probably aware, in 2022, we made a commitment to refresh all states at 6-inch. The data is fully ground controlled, cloud-free, and consistent across our statewide minimum mapping unit, and made available via hard pixel delivery or WMS and WMTS streaming protocols to GIS platforms or custom applications. The baseline content program subscription allows direct and immediate access to the latest vintage of your state's data, either again via a streaming connection or one-time delivery of the hard pixel data. We also allow the identification and enrollment of organizations within the state or directly affiliated with the state to be included for access as well. States currently involved in the content program find this is a great way to ease the financial burden through either the pooling of funding to support the baseline program or to purchase buy-ups and options as part of the Content Plus program, which we'll discuss in the next couple of slides. We offer flexible licensing terms over 1 or 3 years in duration. And really the benefit to states with the 3-year term is the ability to obviously spread the cost over multiple years, while also perhaps if the timing and things fall right, benefiting from the 3-year refresh cycle of the program to gain access to any updated imagery acquired during that window via your streaming access. So for those who don't know what licensed data is exactly, well, in context of the HxGN Content Program, it means we take away the headaches associated with managing an airborne acquisition RFP, as they'd be no longer needed, and actually acquiring, processing, QCing the data, as well as managing the data storage and delivery. All of these come at a cost to your organization, which also includes requisite IT personnel, infrastructure, and the know-how to optimize usage and troubleshoot any issues that may arise in getting the data into your database or to your customers. We also host and manage the data to all of your participants, which limits the need to add costly hardware and software systems that requires further personnel to continually keep pace with these data sets and the market that are continuously growing in size. However, I must caution you that we do place some restrictions on the data's usage. For example, while the data can be shared within the state to registered constituents, the data cannot be posted for public consumption as a general rule. We do allow some of our statewide data to be posted at 2x the resolution of the data, but this is generally handled in a case-by-case basis in our Content Plus offering, which again, we'll cover in the next couple of slides. So in addition to delivery to the state and their constituents, the data also becomes part of the HxGN Content Program ecosystem, which is accessible to other organizations via a subscription. While this may seem sort of counterintuitive to you buying the imagery and it becoming available for others, this ultimately allows you to get the data at a much cheaper price in the end. However, working within the confines of these restrictions, I think most people find that in the end, our easy to access workflows, architecture, extensive data library gives you back the time and freedom to do what is more important, and that's focusing on your customers, your applications, and your user base, which is really the most important piece of the puzzle. On this slide, we see our recently added coverage from 2022 and our planned acquisition areas for 2023. States refreshed in 2022 and planned for 2023 are shown in dark blue and orange on this map and are thus being refreshed at a 6-inch resolution. Our acquisition in 2021, shown in light blue, was split over 1 foot in 6-inch. So therefore, in addition to the dark blue and orange states that you're seeing here, you can add North Dakota, Utah, Delaware, Louisiana, and the metro area of Atlanta, Georgia, to that existing 15 centimeter coverage. So as I alluded to in one of the first slides, for those of you that are looking for a bit more of control of your imagery or something different from our baseline licensed data program, we offer Content Plus. The Content Plus program includes all of what the baseline subscription has to offer, but also includes potential access to a variety of options in buy-ups, such as one, higher resolution focus areas. We've seen some states such as Texas and California take advantage of this by purchasing their metro areas at a higher resolution or at a different cadence than the baseline. Depending on the resolution of the initial statewide coverage, we've seen these buy-ups at 6 inches if the state was collected at the 1 foot level, or all the way down to 2.5 or 2 inches if a higher resolution statewide coverage currently exists. The AOIs do not need to be based on the metropolitan areas, but they can be a variety of different geographic extents, including counties or even council of government regions. There's also the ability to access a variety of collection options, including leaf-off data and acquisitions, higher resolution refresh, and then higher refresh cycles as well. While the Content Plus program does not lead to a full custom data acquisition, we often find that customers get just as good, if not better, data accuracies and resolutions than they were previously using with far less effort, since we take on the burden of the acquisition and data storage and data serving. There's also a variety of value added offerings, including access to our DSM data, and most importantly, our Metro HD offering, which we'll look to ramp up here in 2023 and 2024, which provides 9 high resolution data sets focused on metro areas, which we'll get into a little bit later in the presentation, but that includes very high resolution imagery, 5 centimeter data, 20 points per meter square LiDAR, and a bunch of derivative 2D and 3D products off of that. So when you sign up for Content Plus, the current data for your state is made immediately available through the program. And as new imagery is added, you get access to your spec collect and any other additional program collects during that term of your license agreement. Our pricing conditions enable you to support large, diverse user groups to spread that financial burden around. And then our flexible use terms, delivery vehicles, and user administration tools really allow you to extend the services and pricing across the state. So organizations can work together to share the load, whether it be to a centralized access system or for the data or a funding pool. The HxGN Content Program is trusted by your peers. This slide shows the states currently involved in state and state Content Plus programs. So while the spirit of the agreement remains the same for all of those involved, that is to say the delivery of archived and updated imagery, each state's need is a bit different. So if you're on the fence about participation, don't come to us, go to one of the folks that you may know from the industry, and they can fill you in on all the details. So that concludes our introduction to the Hexagon Content Program portion of the webinar. I'd now like to push on to some exciting developments that we have coming in the content program, the first of which are going to be focused on the sensor side of things. So I'm happy to report that we continue to gain experience with the operation of our new content mapper sensor, as we also prepare to launch an exciting new product, which we'll get to in the next couple of slides. So as discussed earlier, the Hexagon Content Program saw a change in our acquisition paradigm in 2022 that will continue into 2023 and beyond. So that is to say, a shift to a 6-inch pixel for all statewide refresh, and that's made possible by the Leica Geosystems Content Mapper sensor, which you're seeing here. This is a 40,000 pixel cross-track imaging system that allows us to collect double the coverage at the current resolution or double the resolution at current flying heights. So this means higher resolutions over wider areas like we see in statewide programs, and increased flight efficiency, especially during those tighter leaf-off season windows, which allow increased refresh rates and ultimately a more diverse data sets that appeal to some of our Content Plus customers. So on this slide, we see an example of our recently acquired 6-inch imagery from the Content Mapper over Anaheim, California. So on the left side of the image, we can zoom into the wonderful world of Walt Disney. Here you can see the vibrant colors on the rides and the grounds. And in addition to the imagery, we're also providing DSM data for these areas. And so we'll discuss that a little bit later in the following slides, but simply stated, anywhere that we're collecting imagery, we're also going to be deriving DSM data and providing that data for sale as part of the content program. On the right side, we can zoom in on the world of Shohei Ohtani, or more commonly referred to as the Angels Stadium of Anaheim. So once again, you can see the nice vibrant colors, as well as the 3D representation of the corresponding DSM data as well. And like we mentioned, we'll circle back around to that DSM data in the next little bit. So beyond the content mapper, we continue to push our hybrid aerial imaging agenda further into the market, really extolling the principle of fly once and use many times. So our continued effort in this arena is bolstered by, a bunch of general market drivers, as well as drivers from Hexagon's customers, as we really begin to shift and respond towards the inclusion and exploitation of more 3D data. Our latest developments are taking advantage of lessons we've learned with our Metro HD program pursuits, and bringing those into broader and wider ranging areas programmatically and geographically, while at the same time, this allows us to increase the ability to extract more value from our data for our customers, create further content options and opportunities for our customers in the general market, as well as managing some of the operational costs and efficiencies, which allow for better cost control flexibility, which keeps pricing and our costs in check. As I'm sure that most of you can recollect, our first hybrid sensor was the City Mapper that was initially released in 2016 and revamped as City Mapper 2 in 2019. The hybrid data acquisition from multiple 150 megapixel MFC cameras and a 2 megahertz LiDAR workflow really allows us to provide, like I said before, 9 to 10 2D and 3D data sets in parallel using software in our Hexagon Technology Center. As part of our Metro HD offerings. In 2022, we really expanded our processing capabilities and expertise significantly, and now we feel truly confident that we can produce the highest level of Metro HD content at scale. So this really gives us the confidence to eye expansion into the North America market in 2024, but a little bit more on that later. So let's go a bit further as to why we continue to pour our energy and money into hybrid data acquisition. So currently in the market, we have a variety of organizations using imagery only as the foundation for city modeling. However, it's been shown in research and investigation that the introduction of LiDAR increases both the accuracy of the data and the robustness of the reconstruction of the following models. So we believe that having LiDAR and imagery provides us the opportunity to use the best and most comprehensive measurements from each system. Like most of us know, imagery has a high accuracy in the XY plane, whereas LiDAR has a complementary highest accuracy in the Z component. Imagery generally creates very strong top surface models, as the ability to measure and model is really based largely on image resolution, which oftentimes can be more dense than LiDAR. However, as we all know, imagery is a passive and reflectance-based system. So there are limitations when you're operating in shadow or generally low light areas that are not ultimately affected by an active LiDAR system. So this can affect the acquisition window and make operations more complex. And the shadows make it quite difficult to get enough points to accurately reconstruct an area using photogrammetric reconstruction only, and the resultant modeling suffers. So LiDAR as an active sensor allows you to make measurements and produce data even in shadow areas, which bolsters the overall point cloud and resultant models. So also LiDAR has the ability to penetrate small gaps in vegetation, which we know with its multiple returns that allows us to observe the ground in vegetated areas, which is impossible using imagery only. So on the flip side, having image data is much better for interpretation instead of using LiDAR alone, which allows for context, material surface ID, and the classification of the data. And because we're providing 4 bands, including the near infrared channel, we can extend all of this data to calculate vegetation industries, which we're seeing as being extremely helpful as we see a number of cities attempting to characterize their vegetation for a variety of use cases in applications. But hold that thought, because we'll give you a little bit more on that later. And finally, all of our sensor systems are designed with hybrid in mind. So neither system is compromised during design when we're aligning fields of view and GSDs and the requisite point densities. So let's take a look at a graphical representation of what we discussed by looking at some of the inconsistencies in model data that can be alleviated completely or minimized through hybrid data acquisition and processing. So as I referenced before, point clouds generated from imaging only, even if flown with dense overlaps, still show problem areas where point extraction is not good enough. And then we've outlined some on the left side of this slide. So occlusions and canyons. We struggle there due to low light levels and imaging geometry. Which excludes us the ability to match points, which is required in stereoscopic photogrammetric reconstruction. Homogeneous non-textured surface areas. We find these in untextured roads and water. Once again, photogrammetric only algorithms really struggle to confidently match pixels to generate that elevation data. Vegetation, like we mentioned previously, imagery has no penetration. We'll only be able to reconstruct the top of Kennedy and gives us no penetration. And then finally, in shadowed areas where imagery may not be able to confidently reconstruct elevation at all, LiDAR needs 1 point to put on that surface to generate an elevation value. So if we shift our focus to the right side of the slide, here we have a model of a city in Germany, modeled with imagery only alone. I draw your attention to the 3 areas that I've highlighted. You can see improvements in each one of those areas when we add LiDAR to the mix. So starting on the left, we see better vertical reconstruction based upon the conical scattering of our Hyperion 2 LiDAR sensor. In the middle, we see better definition and inclusion in the occlusions and canyons area. And then, sorry, I went too far. And then all the way on the right, sorry, I'm having a little bit of operator error. You can see a cleaning up in the shadowed areas as well. So with all of that in mind, I'm excited and pleased to echo our recent announcement made at Hexagon Live back in June and introduce you to our latest advancement in the hybrid acquisition sensor market, the Leica Country Mapper. So the Leica Country Mapper is the world's first hybrid sensor built for wide area acquisition of imagery and LiDAR. This blends foundational sensor components, our 150 megapixel MFC imaging sensors, operational considerations such as our forward motion compensation, mechanical work, and previous iterations of sensors such as the content mapper, which we talked about, in our DMC4, our city mapper, and is also our 2 megahertz Hyperion LiDAR. It puts this all into one cohesive unit. So this unit really allows us to acquire a diverse array of products efficiently over broad scales in a variety of sunlight conditions. As with most of our sensors, we offer a variety of flavors to suit any and all operation acquisition environments and project needs. So here you can see along the left-hand side, we have an S version, which can produce QL1 LiDAR data and 7.5 centimeter imagery. our H version, which is really focused on QL0 with 5 centimeter GSD imagery. And most of you are probably asking yourself, Travis, I'm not going to buy a sensor. Well, the really important part of this is the Country Mapper W, which is going to give us better than QL2 LiDAR and corresponding 15 centimeter or 6-inch GSD at 10,000 feet AGL. So with this incarnation of the sensor, beginning in 2024, we will begin to phase this sensor in as the new data acquisition standard for the content program. So you heard me right, beginning with some limited state refreshes in 2024, the content program will begin to provide 6-inch data with corresponding LiDAR data as well. So a really exciting advancement that we're seeing in the content program. With the system also comes an improvement, and that is a reduction in laser divergence, which is currently signified as one of the best in the industry. So reduced beam divergence, simply stated, just means a smaller footprint on the ground, which leads to better signal and accuracy, better foliage penetration, and better edge feature accuracy for planimetric mapping. Yeah. The simultaneous data collection of both imagery and LiDAR enables the Country Mapper to generate accurate and comprehensive 2D and 3D data sets in a single flight, which really support a wide variety of customer applications. And further, it allows us to begin to experiment and produce some 3D derivative data products across much more diverse landscapes than are just focused on the metropolitan areas. So moving on, we continue to make progress with our content program data store powered by HxDR, adding new capabilities, streamlining usage, and preparing the launch of new products and services later this year. So for those of you who may not be aware, almost a year ago, our online e-commerce store for 2D aerial ortho imagery moved to HxDR, which stands for Hexagon Digital Reality. From this site, you're currently able to purchase 2D ortho imagery directly from our library after account sign up and activation. And some of the other elevation products and 3D products that you see listed here will start to come online later in 2023 and early 2024 as well. For those of you who may not have taken the opportunity to jump on and take a look at the HxDR system, here we see the landing page for HxDR. If we want to purchase data, we click on the Shop Hexagon Data up here. The coverage of the Hexagon Data Program, content program is loaded in. We can use the filter mechanism located on the left side of the screen to start highlighting different vintages or resolutions. Here we see our current 15 centimeter coverage, and here we see some smaller aerial mesh data sets that we have loaded into HxDR as well. We can also search for specific areas. So here we've typed in Dallas to the search bar. That drives us to the greater Dallas metropolitan area. Once we've added that AOI along the bottom, we see all of the thumbnails and data sets that are available for that given search area. We have a variety of ways to select data for purchase. You can select your entire view extent, which is showing on the screen. You can draw a custom AOI as you see here, or you can upload a shapefile or KML data file to specify the data you'd like to purchase. Once that is loaded in, you see all of the data sets loaded along the left-hand side with pricing to select for purchase. So similar to any e-commerce stores, the data that you want to be purchased can be loaded into your shopping cart and paid for credit card at checkout, and you'll receive an invoice and notice when your data is ready to be downloaded. We currently are visualizing mesh data in HxDR as well. So stay tuned for some further upcoming announcements in this arena as well. So in addition to our Country Mapper announcement, I'm also excited to announce that we're closing in on an expansion to our content program data store. So beginning later this year, we'll start to offer Info Cloud product through the HxDR data store. The Info Cloud data set is really DSM derived from our statewide imagery refresh data. So I told you to park the concept of DSM a couple of slides back. So we'll now be moving and producing this data wherever we're newly continuously refreshing statewide imagery data. So the off-the-shelf product will be based on a 2-to-1 nominal acquisition density, or 1 foot post spacing, which equates to about an approximate 11 points per square meter data set for anywhere we have imagery. Higher density, if that's required, let's say a 1-to-1, which gets you down to about a 6-inch post spacing, that can be acquired through custom order. We won't have that online readily available for direct purchase. That data product equates to about a 40 point per square meter data density. All the data is spectrally encoded with RGB and color infrared data and are delivered in an LAS file format once you receive the data for download. And like I said before, as this data starts to come online, you'll be able to purchase the DSM directly via the web store. So in this slide, we see a short video clip for an AOI near the Salem, Oregon region, showing the density, consistency, and detail of the data. When combined with the imagery that it was derived from, you really have a powerful combination of data that can be exploited for a variety of applications. So I'd be remiss if I didn't mention the delivery schedule. While we're still finalizing specific dates, this is the intended order that the data will be released in, and this is based upon all of our 2022 data acquisition states. So you can see here the list. All of that data will begin to populate on HxDR, and our marketing team will get the word out as widespread as possible to allow everybody to know that this 1 foot DSM data is now available via the HxDR platform. So finally, on HxDR, we're also currently building a rather extensive page of data samples from our countrywide and our Metro HD content libraries that are going to be available for direct download. So if you've never experienced the Hexagon content data firsthand, I encourage you to visit the content data store in the coming weeks on the HxDR platform. Download some data, and especially our Metro HD data. Get it into your software, get it into your custom applications, and play around with it, and let us know what you think about it. We've provided each data set that you see here in a variety of formats that can be loaded directly into most GIS software platforms and a variety of custom applications as well. So once you're in the shop, the data samples can be found in the featured data tab on the main menu, which appears along the left side of the screen and will look very similar to this interface that you see here. So where are we ultimately headed with the Metro HD program? Well, like I previously stated, we've now built the infrastructure and refined the product to begin further expansion, both programmatically and geographically. So currently we're eyeing a variety of cities in North America that we could begin acquisition in the closing quarters of 2023 or the first quarters of 2022, so 2024. So please keep an eye out for those further announcements in the coming months. And so as you may notice, our initial expansion will be timed sort of opposite our content program acquisition. So we'll be focusing on the more southerly states for the time being that are less affected by leaf-off scene content. But it's not too late to get your vote in. So please let us know if there's a specific area you'd like us to focus on. I'd also like to tease a new product that we're currently developing in partnership with Cyclomedia. So those who aren't familiar with Cyclomedia, Cyclomedia is a Dutch-based company with offices in the US as well, and they specialize in the large-scale and systematic visualization of environments based upon mobile LiDAR and imagery data. So this product, which we've affectionately titled Super Mesh, is a combination of both aerial and mobile mesh data to provide a comprehensive view of the scene at the highest level of detail and accuracy possible. Obviously, the ground or street level scenes are based upon the mobile LiDAR, and then sort of the top or restricted areas that can't be seen by the mobile platform are then filled in by the aerial mesh data. So not really ready for purchase yet, but I thought I'd get it out there and tease it since we were talking about so many new and exciting things. I really couldn't hold back. So I'd like to spend the remaining time that we have here discussing some case studies from two very different yet important customers and partners in the Hexagon ecosystem. The first is Land Info. So Land Info is a company based out of Madison, Wisconsin since 1993. Land Info has been an early adopter of the HxGN Content Program, and it has really evolved their practice along with our data library throughout the years. The company is now run by Nick Hubing, a 26+ year veteran of the geotechnologies industries, working together with a team of highly trained and specialized employees, all of whom have prior professional experience in mapping and satellite imagery. The value that we see Land Info bring their customers is evidenced by their unrivaled growth, multiple times being recognized for their fast growth and great company structure. So today we'll explore Land Info's tree mapping product that relies on HxGN content data. The catalyst for developing this capability really arose from the need to better handle the susceptibility to obstructions when deploying 5G in the city of Chicago. So as you know, 5G technology can provide very high data speeds, but can be limited by signal blocking from objects. A lot of the objects that block it are currently pretty well mapped. However, tree data is not often very well mapped. So Land Info saw an opportunity there. As you can imagine, the product, however, has developed and morphed over the years to now provide support to a variety of applications, which include some of the applications and use cases listed here. So obviously 5G, identifying dangerous trees, mapping of green space, solar potential, and wildfire risk analysis and mitigation. Well, I don't want to get too far into the weeds. I do want to point out some details surrounding the work. This is an object-based process that's been evolving over the past 20 years and has proven itself time and time again to map trees at scale using a variety of imagery data. The algorithms can function with or without elevation data, but with elevation data is obviously really preferred. So as I mentioned on the last slide, the algorithms can use multiple imagery data sources, but aerial data is really preferred for the 5G application. So while the satellite data has really dominated the telco mapping historically, the push to the 5G rollout is requiring a much higher level of detail and fidelity of data. And Land Info also finds the cloud-free consistency and native geometry of the aerial data, and especially ours in the content program, really tremendously improving the overall results versus satellites. And this may even worsen as the satellite moves to small sats to reduce launch costs, which will also decrease the swath width as well. So this slide shows a typical example of some tree mapping products widely available. As you can see, the imagery on the left represents tree stands with uniform heights applied across the entire coverage of the polygons, while the image on the right slightly improves the results by providing some form of individual tree crown recognition. But in the end, you can see the appearance is not really modeled to the real world. You know, I myself have not really witnessed a lot of cylindrical trees, but at least, you know, this is a step in the right direction. So Land Info's approach really tries to improve on that concept on the right. To achieve the higher level of tree mapping, Land Info employs obviously a multi-step process that includes first delineating the crowns, then estimating the trunk location and the crown diameters, and then contouring those crowns and readying the final product for use in further geospatial analysis. So once again, we're whisked away to Disneyland on this slide as we see the inputs to the process. On the left is our 4-band 6-inch data that was recently flown in 2022. And on the right, we have the corresponding imagery-derived info cloud elevation data that I presented on earlier. However, what you're seeing on the right is a bit of a specialized product, and this was run out at 6-inch resolution and not the standard 1 foot that we'll be providing via the HxDR platform. So, you know, the next couple of slides, let's just sort of step through the process so you can get a feel for what Landinfo does, so that you could possibly contact them for maybe some tree mapping work in your area. So it's important to note that all the output in this series is based off of Imagery and elevation from Content Mapper. The only additional layer to the process is a 3-depth layer for DTM, which was used to derive normalized heights. So obviously, the tree mapping starts with a single tree classification where individual tree crowns are identified. Then from there, trunk locations and height and diameter are estimated. And the attribution is then generated and included as part of the final 3D tree mapping output. So from there, the trunks and the crowns are combined. And the next step involves extruding those individual trees. But as you can see here, this is not really a finished product, as all the trees still have uniform heights for canopy, and they have not yet been contoured. So that's where the final stage of the process comes in, as each one of the crowns is contoured individually, which leads to an intermediate data product that looks like this, and then a final data product that looks like this. So you see very good representation of the actual tree structure in the data, in the final data product. So one more case study before we finish here. So our next case study is really going to focus on our recent expansion of 3D data processing capabilities, from really sort of in-house to production at scale levels. So, this is all I've alluded to previously is what positions us well for further expansion of the Metro HD program into North America, as we've now built and tested our workflows and resultant data products, as you're going to see here in the next couple of slides. So if you'd like to further investigate the data, which I'm showing, I encourage you all to sign up for an HxDR account, search for the Netherlands, and here you'll be able to observe the fruits of our labor. So this case study that has been in partnership with Cyclomedia will really serve as an outline to what we will be able to achieve with the Metro HD program in the coming months. So since 2018, Cyclomedia has been providing street level visualizations using LiDAR and image data collected from vehicle mounted sensors. They have a variety and broad range of applications from commercial and municipal activities in their portfolio. But in the recent past, they really started to recognize an increased demand for 3D data, especially in the Netherlands. So Cyclomedia began to envision a similar market offering based upon the aerial perspective. Their hope was that if this offering could not only maintain Cyclomedia's position as a premier content provider, but also create a new way for customers to interact with real-life 3D models for work processes that rely upon the highly accurate data that they've come to know and appreciate from Cyclomedia. And then further objectives really included creating a multi-purpose 3D model that aligned with the Netherlands' overall geospatial strategy to push to 3D, the production of products at scale with refresh rates to keep data current, and that would really position themselves and their corresponding street smart platform as a total solution for providing high quality content with easy to use functionality, visualization analysis. But the way to go about this was a little convoluted. So how do they achieve this? Well, they were considered a market leader in their own right. The expertise required to process over 36,000 square kilometers of aerial data was a bit of departure from their normal operations. So Cyclomedia went out in search of a creative business model that could bring their vision to reality in the most efficient and effective ways possible. So as a result, a partnership business model between Hexagon and Cyclomedia was formed based upon the notion to allow subject matter experts to be their respective subject matter experts. Allow those who know to focus on what you do best and partner with those who bring specific expertise to the table that you do not have. So this is where the Hexagon Content Program begins to fit into the picture with our means, familiarity, and ability to acquire, process, and publish data on a national scale. So the solution, known as 3DNL, is the first of its kind, which is a photorealistic digital twin of the entire country of the Netherlands. And this is based upon aerial imagery and LiDAR data as collected by like a Citymapper 2 sensor and processed within Hexagon's visual computing environment and made accessible to Street Smart via HxDR. So it's really tying all the pieces and parts that we've been talking about today together to provide a really comprehensive data solution. So in the next couple of slides, let's explore a bit in more detail the frontline technologies that really made this all happen. So pictured on this slide is once again like a state-of-the-art Citymapper 2 hybrid airborne sensor. The sensor is perfectly suited for efficient and accurate urban mapping and 3D model reconstruction by collecting both nadir, oblique, and LiDAR point cloud data. As can be seen on the right side of the slide, the imagery capture technology is optimized to collect brilliant, occlusion-free imagery in complex illumination environments by deploying a mechanical forward motion compensation operation. And then the oblique scan pattern that you see down below really allows us to not only collect really high quality and dense LiDAR data, but you can also see the representation of the facades of buildings, which is really important when you're reconstructing the metro areas. So the benefit of this approach is a comprehensive, accurate, and consistent representation of the scene, textured with the sharp, high-resolution imagery that brings these models to life. So here we see the imagery products that were created, ortho data, oblique data, and then down below the variety of LiDAR data that is also produced by the Citymapper 2 sensor. So how do we generate a fully realized 3D model? That data needs to be subjected to a much higher level of processing. So located within the Hexagon Technology Center is Hexagon's visual computing environment, which has the ability to reconstruct the natural and urban landscape in 3 dimensions using the Citymapper 2 data. The market differentiator for our software is obviously the ability to take advantage of the Citymapper 2 data and process the data using both LiDAR and imagery inputs for final model. The software is specifically designed for large-scale parallel computing environments, which allowed us to acquire, process, and deliver a very large amount of data in a very short amount of time. So looking at the data workflow here, we also rely on our HexMap software to create some of the preliminary data sets, the LiDAR, the oblique data, and the ortho. That's fed into the Hexagon visual computing environment, where the data sets that you see on the right and delivered as part of our Metro HD program are generated. So the HxDR platform added the flexibility to accommodate Cyclomedia's technical needs for data distribution, purchase, and usage. The highly qualified HxDR team was able to use the current platform that we have in place as a starting point, and then built and developed capabilities to really bring Cyclomedia's vision to reality. And so this went beyond simply visualizing the mesh data, but further to creating an API to stream that data directly to Cyclomedia's Street Smart platform for use in direct stream mode, and the ability to clip and ship those areas for customers that wanted that data downloaded to their own systems as well. So the HxDR platform was really the catalyst that made certain the high quality 3DNL data set was instantly available to Cyclomedia's diverse user group. So here we see the country of the Netherlands in HxDR on the right side of the screen, with the white outline representing the boundary of the 3D model coverage. So zooming in on a select spot near The Hague, we're able to visualize the 3D model in its true form, and then further see that data being streamed in to Cyclomedia's Street Smart application, where their users can leverage and use the data. So as mentioned earlier, HxDR provided the conduit for providing the data to Cyclomedia, which facilitated the digital environment to which its stakeholders can use. But Cyclomedia also provides a simple way to access the hosted data, and also includes visualization tools, plus other key features and functionalities such as shade analysis, importing and visualizing CAD data, BIM, and reality capture data, as well as taking cross-section and measurements, and really working and collaborating and using the data that we are streaming from the HxDR platform. So they've noted that there's a broad range of applications that appeal to both government and commercial customers. Solar companies are using it. City landscapers are using it. Construction and engineering companies can download an area of interest, design a new build, and then determine the most efficient access and logistics for either the construction phase or the usability and operation phase after that as well. So finally, I just want to take a little bit to outline the effort involved to produce some of this data. So as a part of this mapping effort, over 100,000 kilometers were flown, over 640 flight hours that covered about 40,000 square kilometers of ground data, which generated about nearly 500 terabytes of raw data, and just a little bit under 2.5 million images. And you can imagine the amounts of LiDAR points from there. That generated close to 280 terabytes of imagery products, 60 terabytes of mesh, and throughout the process, we were able to improve our workflow and our data products to the tune of about 2.5x in throughput per day. That data is automatically processed, QC'd, and published to HxDR, and then ultimately Street Smart for direct consumption as well. So with that, I will conclude my presentation by outlining ways in which you can contact the sales programs. I've listed two of our best sales personnel here. For standard data resales, you can reach out to Kimberly Nail. If you don't know Kimberly, she can be reached at the following email address. And then for more complex or larger data programs, feel free to reach out to Jamie Curtin, who's our VP of Global Content. And with that, I will thank you for your time and attention, and can turn it over to questions if there are any.
Yeah, there are a few questions in the chat box here. So the first one I see is the LiDAR classified? And if so, to what level is it classified?
So the LiDAR data is currently not classified. We're working on some automated classification algorithms. So that's on the roadmap for later on this year or early 2024, where we'll have the option to provide that classified data. We'll probably start initially very simply with ground versus non-ground, but then we'll look to add some basic ASPRS classes to that as well.
Awesome. Next question, /observation. It seems that it takes up to 8 months for the 15-centimeter product to be available via the content program after acquisition. Are there any plans to speed that up, or perhaps provide a preliminary product via Content Plus sooner?
That is an excellent question. Yes, we are looking in ways to speed that up as well, be it through hardware processing acceleration. But you hit the nail on the head with maybe we're also looking into a preliminary data product that goes online in a much earlier time frame than that 8-month turnaround, so people can start using the data with the caveat that it's being sort of improved on the fly, or if they're happy enough to use that maybe not 100% QC'd data set, they can certainly use that. But yeah, we're looking at ways to bring that to the market more quickly. And yeah, one of the solutions that we're looking into is actually providing a preliminary product for use.
And Taylor would like to know what classes are included in the land cover product.
That is actually dependent on what area we are mapping. It's an AI approach. So we have a wide range of land cover classes. If you want to, I can't name them all off the top of my head, but if you can think about the general land cover classes that are in your area, they're probably included in that mix, or you can reach out to me directly and I can give you that information.
Great. And the last question that I see here is, are there any plans to add wide area oblique imagery to the content program outside of urban cores in the US?
Boy, this is really hitting on all cylinders today. Yes, there is. We actually just started the discussions to come up with a mechanism to start taking oblique data and getting it into potentially a viewer mechanism that people can start using that oblique data. So yes, there are plans, and it's on the roadmap to begin delivering some of the oblique data in the coming months and years as well.
Right. Well, that's the extent of the questions in the chat right now, but if anybody else has any, we've got a few more minutes. So. All right. Well, thank you everybody for attending. Travis's information is on the screen there if you have any follow-up questions. And Travis, thank you so much for the wonderful presentation and your time today.
Thank you, everybody.